Now, let's see how disaster recovery happens in Azure. So when it comes to disaster recovery, the service that runs in the backend is Azure Site Recovery. And the service that you see on the portal is Site Recovery Vault. Sorry, Recovery Services Vault. So Recovery Services Vault is a container service which has the capability for both backup and disaster recovery. The service that actually participates into the disaster recovery, the name of that service is Azure Site Recovery. If you want to see how that service works, first of all, that service is equally compatible. So this is how it happens. Now this is for Zerto. Just give me a moment. I'll show you from here. This is the image. Okay, let's understand how it happens. So this is my region 1, which is my primary region. Let's just imagine that I have a 3-tier application which has 2 web servers, 2 application servers, 2 database servers. Okay, it's a 3-tier application, and this is highly available application because if you look carefully, the web servers are getting load balanced, application servers are getting load balanced. In fact, the database is getting load balanced. So I have 2 instances of each tier in an availability set, which gives me 995% of availability. This is my, this is my configuration or infrastructure at the primary site. And this configuration is giving me 99.95% SLA because it's an availability set. And all of this is in a virtual network. Now, all of these virtual machines have disk, OS disk and data disk. Now, how this service is working, Azure Site Recovery. So what Azure Site Recovery is doing, Azure Site Recovery is copying all the disk similar to backup. In backup, the copy operation is done in the same region, but here the copy of these disk, OS and data disk for all the virtual machines, which includes the virtual machine configuration and all that, is getting replicated. This is known as replication, or copy is getting replicated into a different region, which is my West US region, because my primary is East US, or my paired region. And when the disaster happens, from these replica disks, these virtual machines will be provisioned with the similar configuration that you have on the primary site. All you need to do is at the DNS level. If you're not using a DNS load balancer, which is traffic manager, what you need to do when the application is made available from the DR side, you just need to go to your DNS server or DNS registrar, public DNS registrar, and there you need to bind your application URL, which is www.cloudexperts.com, with the new public IP that you have at the DR side. That's it. No other change needs to be done. Everything will continue to remain as it is. So that's the automated disaster recovery that you can perform using Azure Site Recovery service, which helps you to bring down the RTOs and RPOs. Now, what is RTO and RPO? Can somebody tell me what do you mean by RTO? Recovery time objective. What is RPO? Recovery point objective. These are two terminologies which we use in disaster recovery scenarios, RTO and RPO. RTO is recovery time objective. Recovery time objective means time to bring up the application at DR site, or total time taken to bring up the application, or the amount of time where your application remains unavailable. That's recovery time objective. So example, the disaster happens at 12:06. It took 2 hours to bring up the application at DR site. So what is the RTO? 2 hours. That would, I took 2 hours to bring up my application at DR site, or I had 2 hours of outage. That recovery time objective. What is recovery point objective? Amount of data loss. That's recovery point objective, which once again, it is 12:06. It took me 2 hours to bring up the application at DR site, and I lost last 30 minutes of data in that process. So my recovery point objective is 30 minutes here. Amount of data lost, I lost my last 30 minutes of data. And it took me 2 hours to bring up my application at DR site. Now, what is the ultimate goal for an organization when it comes to a efficient disaster recovery strategy? What is the goal? Do they want to increase the RTOs and RPO, decrease it?
Decrease.
Decrease, absolutely.
It's a zero would be the best.
Zero will not be possible. So as minimum as possible. Okay. All right. So any RTO which is 2 hours and below is a great RTO. That's the acceptable time frame. When disaster happens, nobody will expect you to bring up the application, just by a flip of a switch. No, 2 hours is okay. And RPO, I'm saying there has been debate. There have been tools. For example, the other slide that I was showing you from Zerto. Zerto is an enterprise or leading disaster recovery solution that enterprises uses across the globe, and it promises an RPO of as minimum as 2-3-5 minutes, below 5 minutes of RPO, and RTO as minimum as 1 hour or a couple of minutes. That's Zerto promises. Now, it is actually the strategy, it is actually the planning that saves a lot of time. If you plan your disaster recovery strategy well, if you perform disaster recovery drill exercises once in 6 months, and after every exercise you document how much RTO and RPO you achieved, and you identify the steps to automate the process to reduce the RTO and RPO, your disaster recovery strategy will refine with each disaster recovery drill that you perform. And it's a mandate. SOC compliance, ISO 27001 compliance. If your organization is aligned to those compliances or need to comply, you will need to perform a disaster recovery drill once in 6 years, twice a year. Some organizations perform once in a year, and you will need to document every minute aspect of that exercise and share it in the form of a report with the auditor. If you have to comply with SOC 1, 2, and 3 and ISO 27001. So that's the disaster recovery part. This is how it happens. The ultimate goal of this exercise is to reduce the RTOs and RPOs as much as possible, create a strategy, identify the team, document every minute aspect, so that when the disaster happens, you're able to follow that document, DR document, and you're able to perform the disaster recovery. If you want to see a typical DR document, let me quickly show you that how a typical DR document looks like. All right, so basically organizations create a disaster recovery document in which they document every minute aspect of the disaster recovery strategy, which includes who all are the team members, what all applications are part of disaster recovery, what is the individual RTOs and RPOs target for those applications, who are the application owners, during the time of disaster, who should be contacted, who are the primary and secondary contact, what is the process of recovering an application at DR site for each application. All the information is there in that documentation. And then when you perform the disaster recovery drill, you create another documentation which actually talks about the process that you followed, any learning, challenges, outcomes that you identified, any risk that you identified, what was the RTOs and RPOs that you achieved, what steps you could have taken to, to reduce those RTOs and RPOs. All that information is documented in that report, and you share it with your auditor. So I'll show you both the information after lunch. Okay, let's just, so enough of theory, let's just configure the disaster recovery. Now that you've understood the process, now this is also a cost-effective solution. Can you tell me why it is cost-effective as compared to traditional on-premises disaster recovery sites? Why this is a cost-effective solution?
See, I mean, we don't have to have multiple hardware sets for everything, right? The basic reason it's like everything.
Great. That's exactly what. So typically what happens, a traditional disaster recovery sites are like cold DR, hot DR. What they are, cold DR and hot DR mean. Hot DR means that your disaster recovery site has the similar infrastructure as that of primary site. And it has similar infrastructure, and there's a continuous replication or synchronization of data which is happening. That's hot DR. It's very expensive because if you're spending $1,000 a month on your primary site, you're spending the same amount on your DR site. And if the disaster does not happen for 2 years, it's like buying an insurance policy. You purchase it, and you know that in case of untoward situation, in case you're not there, your family is protected. Your family does not go through that financial crisis. So here it is your corporate that you're spending $1,000 every month, $12,000 a year, and you continue to spend that amount, and you always hope that you never need that amount, right? So it's like purchasing an insurance policy. Disaster recovery is similar to it. So hot DR is where the infrastructure is there, redundant infrastructure is kept at the DR site, which is a cost-effective solution. Then there is another concept which is cold DR. Cold DR means you have the DR site configured with hardware, but at reduced capacity. So if your primary site has 2 virtual machines for each instance, on your DR site, you will have 1 virtual machine, let's say. So what will happen when the disaster strikes, when your application goes live from your DR site? It is running on a reduced infrastructure. There could be some performance issues. It will not give the same performance as it was giving at the primary site. That's the only drawback to this, to this arrangement. But both the arrangements have some cost associated with it. But if you look carefully, the arrangement that you see on your screen does not involve any hardware at the DR site. It only involves the replica, storage, or the configuration of your virtual machines at the DR site. And in the event of disaster, you are bringing up the environment. You are actually building that environment. And this Azure Site Recovery Service is responsible for it. It quickly builds up the environment. Within a couple of minutes, it builds up the environment. So that's where you're saving a lot of hardware cost. That's the benefit of this strategy. Now, Azure Site Recovery can be used for configuring disaster recovery for Azure VMs. You can also configure it for the configuration of disaster recovery for on-premises VMware-based virtual machines, Hyper-V-based virtual machines, and physical servers as well. That's the beauty of this service, that it also expands across various on-premises solutions. So an on-premises VM-based VMware and Hyper-V and physical server can also be configured for disaster recovery using Azure Site Recovery, right? That's the beauty of this service. Let's use this service. So we'll go to the disaster recovery vault now. This is my DR vault.
I was going to say, I think that's one of the recommended options available when you want to migrate from on-premise to cloud too, is it not?
Absolutely.
The site recovery?
Yeah, you can also use this service for the migration as well. However, in Azure, they have created a separate service for migration with the name Azure Migrate. Now, Azure Migrate also uses Azure Site Recovery in the backend, but you will not find it written somewhere. So that's how Azure works. It is Site Recovery Service, which is doing both disaster recovery and migration, but the name of the service is different on the portal. but in the backend, it is the same service.
Yeah, I think a couple of years ago I was reading about the site recovery. That's the only reason it sticks
Yeah,
in my
it's the
memory.
same service. They changed the name. In fact,
Perfect.
yeah, in fact, there is only one difference between migration and disaster recovery. The difference is, in case of disaster recovery, you do a rollback. I'm saying you actually do a failback. So let's say you have your primary site. Let's say you use Azure Site Recovery service to configure the disaster recovery for a VMware based on-premises infrastructure to Azure. Now the disaster happens. You trigger disaster recovery using Azure Site Recovery, and your application is live in Azure. It is functioning from Azure while you make efforts to bring your on-premises VMware-based site up and running. 2 hours later, your primary site comes back up. You resolve the networking issue or whatever issue was there, or let's say a couple of hours later, it comes back up. You will perform a failback, which means now you will replicate all the delta changes that has happened while the application was up and running from the DR site back to on-premises VMware site. Once that replication is 100% complete, you will do another failover and your application will be live from on-premises. That's disaster recovery. In case of migration, you don't do a failover. You only do a failover from on-premises to Azure. You validate your application in Azure, and then you shut down your on-premises environment. That's migration. So migration and disaster recovery has this fundamental difference. The tool which has the capability of disaster recovery can also be used for migration, but not vice versa. If there's a tool which only supports migration, not disaster recovery, it will not support the failback part. But if there's a tool that supports failback, disaster recovery, by default, you can utilize that tool for migration as well. I hope I'm making sense, guys.
Sure.
Great. Let's talk about disaster recovery now. So we'll once again we'll configure the disaster recovery for both the VMs. We have configured the backup. Now we'll configure the disaster recovery. So we'll go to the site recovery vault. Now, as I said, there are two options. Once again, either you go to the VM and under operations on the overview blade under operations, you click on disaster recovery and you configure it from here, right? But if you do it, you will do it for all the VMs one after another, which will take a lot of time. Let's not waste time. Let's use the service to configure the disaster recovery for both the VMs in one go. Or let's say if you have 100 VMs, you can configure it for 100 VMs in one go. So we'll go to the recovery services vault. This time we'll select our DR vault. So we'll click on the DR vault. Now, as I said, now you are in the DR vault. So you will only work with the services related to the DR, disaster recovery. So I'll click on getting started here. And this time I'll select site recovery. Now, when I select site recovery, it shows me three options. As I said, site recovery service can help you configure disaster recovery for Azure VMs, for VMware to Azure, and Hyper-V to Azure. So I'll select the first use case and I'll click on first option that says enable replication. Now, when I hit enable replication, it will ask me a couple of questions. So first question, similar to backup, which is my source location? By default, it is selected East US because Azure also knows how your environment is configured. But if you have other location, you can select it. So I select my source location as East US. Azure Virtual Machine Deployment Model as Resource Manager. As I said, Azure has now second version, which is Azure Resource Manager based deployment. So by default, it is selected. If you see, it also says classic. Classic means that you have some virtual machines from the olden days. So you'll select Resource Manager, which is by default selected. Then it says select the subscription. There could be a probability that you have more than one subscription. Select the subscription. Then it says select the resource group where your VM resides because you're going to configure the replication. So I'll select my resource group, training RG. Then it says disaster recovery between availability zones. By default, it is no. I'll keep it no. So I've selected my primary region. I've selected my subscription. I've selected my resource group. These are the three things that I've selected. Then I'll click on next. When I click on next, since you have selected the region and resource group, all the virtual machines which are part of that resource group will be displayed on the next window already. So since I only have two virtual machines in the region as well as in that resource group, both the virtual machines are shown here. I'll select both the virtual machines. Then I'll click on next. Now, when I click on next, either I can configure my DR site components by myself, or I can let Azure do it. Because on the DR side, now let's understand this. So on the DR side, you also need a network, because when your virtual machines are provisioned at DR side, would it not require a resource group? Would it not require a virtual network? Would it not require a public IP? Would it not require a load balancer if your virtual machines are load balanced? It will require all of those services. It will also require storage accounts. It will require disk, and it will require all the services. When you trigger the disaster, when the disaster happens, when you trigger the disaster recovery, it requires all of these resources at the DR site. So there are two options. Either you leave it to Azure to take care of it, so that Azure will create a resource group, Azure will create a virtual network, Azure will create public IPs, Azure will create load balancers and all for you when you trigger the disaster recovery, or you create your own infrastructure at DR site and point your virtual machine to that infrastructure, which means that you can say that, okay, I am configuring disaster recovery for these two virtual machines. When the disaster happens, when I fail over, when I perform the disaster recovery, which means failover, these two virtual machines should get provisioned in this resource group, in this virtual network, in this subnet, this public IP they should pick up, this load balancer they should be behind. So I can also do that configuration. To make our life easier, we are not getting into that detail, but I'm just sharing that this option is also available, and typically in a production scenario, you perform it like that. But for the lab perspective, we'll just let Microsoft take that pain. So we'll just go with the customized settings here. We'll just go with the default settings. So if you quickly see target resource group, what Microsoft is doing, whatever resources that you have at primary site related to this virtual machine, Microsoft is just adding a suffix with -ASR there, and Microsoft creating the same resource. For example, you have a resource group at primary site with the name training RG. The target resource group will be training RG -ASR. Target virtual network would be training RG, training VNet. PS means primary site -ASR. So that's what Microsoft is doing to make your life easier, instead of you go ahead and create all of these resources manually. Then there is a replication policy. Now, similar to backup policy, you also have a replication policy, which is a default policy in Azure, and we go by the default policy, which says that it should only retain last 24 hours of data. When you perform a disaster recovery, can you think of a scenario wherein you will say that, you know what, I want to perform a disaster recovery, but when my application comes up at DR site, it should have data which was equivalent of 30 days ago or 3 days ago. Is that a viability? Is that possible? I'm saying, do you think that this scenario can exist for disaster recovery? Yes, no, maybe?
I think it would be very rare.
Yeah, it never happens. When you want to perform a disaster recovery, you want your application to be up and running at DR site with the most recent data, not the data that it had 2 days ago. What is the purpose of disaster recovery there? So that's the reason we go with the default policy, which says 24-hour replication. It replicates the data for 24 hours. Just give me one. All right. So the recovery point retention means, ASR will also create a couple of recovery points, and it will retain it for 24 hours. And after 24 hours, it will just discard them. So at any point in time, when you want to perform a disaster recovery, you can select a retention point for the last 24 hours. But the best practice says that we will always select a retention point which is the most recent, because our objective is to reduce the RPO. If I select a retention point which is 6 hours back in the past, then I'm losing my last 6 hours of data. So I will always select the most recent. So this is the replication policy. I'll just enable replication. That's it. I've selected the source region. I've selected the resource group. Then I've selected the the virtual machines that I want to configure disaster recovery for. Azure has by default, created all of these services. Azure will create, and I'll just click on enable replication.
Now target location, we have taken West US, right?
Yeah, by default it's West US because your vault is in West US. So this this protection or this disaster recovery protection is happening in that vault only.
Thanks.
Okay, now what it is doing in the backend? What Azure Site Recovery will do, it will install a small agent which is known as ASR agent or Site Recovery agent. It will install that small software or agent on the virtual machine, which will replicate all the data and configuration of the virtual machine to a storage account at the DR site, which is known as cache storage account. It will replicate all the data there. It will first do a full replication, which means initial seeding. Seeding is the word that people use for it, or it is also known as synchronization. It will copy all the data from the VM. Data means the VM configuration and the data which is kept on OS and data disk to the DR site in a storage account, which is known as replica disk. And once the initial copy is complete, initial synchronization is complete, then it will continuously capture the data changes that happens on the virtual machines. Data changes means any change in the configuration of the VM, any change in the data which is kept on the OS and data disk. It will continuously replicate the data changes to the DR site. And this process is near it is near it is near time synchronization, not real time. Why I'm saying near time? Because there will be a lag of a couple of minutes depending on the bandwidth between the two regions, depending on the traffic between the two regions. So it's a near time synchronization, and Azure Site Recovery will ensure providing you RPOs as minimum as 5 minutes, and at times it also goes into 1 minute or less than 1 minute. That we will see. So we have configured it. Now, after that you have configured it, if you want to see the current status, you can either click on this notification where you see enabling the application for 2 VMs. You can click on it and it will show you what's exactly is happening in the backend. So you're saying that right now it is creating a site which is in progress. So it is creating that DR site for you. And what it will do, it will also create that site, then it will register both the servers, then it will deploy the agent on both the servers and configure that agent to communicate with site recovery service. A lot of activities happens in the backend, because of which this entire process takes a couple of minutes to complete. So while this process gets completed for our respective VMs, I hope everyone who's following me while I configured it and you also configured it for your respective VMs.
So Raghu, Raghu Dilip here, sorry. So when I was trying to replicate at a time, it allowed only one VM. When I selected both the VMs, it did not allow. Why so?
But it allowed for me. I selected both the VMs, and I hope others selected both the VMs.
Same happened with me, Raghu, as well.
It didn't allow me to select both the VMs. So I just created this recovery site only for one VM.
Okay, it did not allow you to select both the VMs. And who else could select both the VMs? But you see that I was able to select both the VMs.
Yes.
Yeah, it's worked for me. Yeah.
If it did not allow you to select the VMs, I'm saying the question is, did it show both the VMs, or it did not show both the VMs?
No, it did show both the VM. When I selected both check marks, it gave some error, but I failed to capture it. But I just selected one and then I created site for one.
Okay, no problem. Once you can also do it for the other now. While the one is in progress, you can do it for the other. You can follow the same step and do and enable the replication for the other VM also.
Okay.
All right. So that's what you need to do now. As I said, this will take some time, guys. So let's take quick 15 minutes of breather while this process completes, and we'll move on to the next topic. We'll use the same. I'm saying we have configured backup, we've configured disaster recovery. Now we'll do load balancing for the same environment, and we will validate everything. Once this is configured.